This is a topic that we are starting. It is called gas volume. I just want you to follow me clearly and attentively. So the other name for gas volume, this is just the same as the molecular. So we just say molecular volume of gases. Molecular volume of what? Of gases. This is another name. So when we say this is a gas volume, it is just the same as the molecular volume of gases. And for you to understand this one, it gets to fall under a law that we get to call Avogadro's law. So it gets to fall under this law. And for you to understand Avogadro's law, you need to understand the formula we get to use where we say number of moles is equal to volume over molar volume. So this is the formula. Number of moles, I guess some of you that have not covered more concept, you are getting to hear of this for the very first time, or this particular formula. So this is another formula you can use to calculate the number of moles, volume over molar volume. So now from this definition, you are able to tell me that this one, if you've done mathematics very well, or if you use mathematical eyes here, you're going to tell me that volume is directly proportional to the number of moles. Have you seen? So you are going to tell me that Avogadro's law states that. So you are going to start, it states that, this is what you are going to say. It states that the volume, so you are going to start with the what? The volume states that the volume, so we are saying that the volume of a gas, it says that the volume of a gas is directly, this volume is directly proportional to the number of moles. So volume of a gas is directly proportional. This is what I'm saying. Directly what? Directly proportional to the number of moles of a gas. To the number of moles of a gas. To the number of moles of the gas. Have you seen? Of the gas present. So of the gas present. There is a condition that is now attached where we are going to say that if pressure, so if what? If pressure and temperature are constant. So this way, this temperature, you are going to complete it. Temperature are what? Are constant. This is what you are supposed to understand. So this have you seen this whole thing here is just coming from this simple formula. So once you know the formula, it means that you even know what Avogadro's law states. So we are just analyzing this. You can forget about this. You can put this in your own ways. You can tell me that Avogadro's law states that the number of moles of a gas present are inversely proportional to the molar volume. It is just one and the same. I'm interpreting this based on the mathematical knowledge that I have. You know that number of moles is directly proportional to volume, but inversely proportional to the molar volume. This is what we are actually talking about. So from here now, you are going to discover that if you are told to calculate volume, you are going to say volume is equal to what? Volume is equal to number of moles times molar volume. So if you want to calculate volume, this is another formula you can use. Have you seen? So I've just put one there, then cross multiplied. So these are important concepts that you are supposed to know. The good part is that I've given you formulas and we've done a lot of things on how to calculate the number of moles. I guess no one can tell me that I can't calculate the number of moles. Those things are very simple and I know you can answer them out. So the molar volume, this one here, this one is called what? This one is called molar volume. So the molar volume that is here, There are certain things that you need to understand. There are certain things you need to know. This molar volume, it can be at RTP. So molar volume at what? RTP. The molar volume at RTP, this is room temperature and pressure. So at RTP, you need to understand that the volume, you need to get that the volume of 1 mole, the volume of 1 mole, the volume of 1 mole of any gas, is 24 cubed dense meters. So this is something you are supposed to know. So the volume of 1 mole of any gas at RTP, it is what? 24 cubed dense meters. And I also want to submit this to you, that this 24 cubed dense meters, it is just the same as 24,000. It is just same as 24,000 centimeters or cubed centimeters, like this. It is just one and the same. So these are certain things that you have to understand. It is just one and the same. But whenever we are talking about the molar volume at what? STP. That is what we call molar volume at STP. What is STP? Standard temperature and pressure. So when I say STP, what I mean is that this is standard temperature and pressure. If you can forget these things, it's better you write them somewhere. Room temperature and pressure. This is RTP. STP, if you know that you can't keep this for a longer period of time, when you are starting, you can forget this. It's better you write it somewhere. So what I'm saying is that the volume, here it's that the volume of the volume of 1 mole of any gas, the volume of 1 mole of a gas, of a what? Of a gas at what? Let me do this. At what? At STP. At STP is what? Is 22.4 cubed dense meters. This can also be written as 4,000 cubed centimeters. So this is what we get to mean. I guess you are writing down notes. Even as we are advancing, we are moving together. So this is what you are supposed to know. These are questions that you have to understand. So we are almost concluding this topic called stoichiometry calculations. We are almost concluding this particular topic. Let us now look at a question. We look at a question. We see how questions do come in an exam. So how do we expect questions? I'm giving you time to copy down what I'm explaining, some notes, just like that. So let us look at an example. So I say example. This is what? Example 1. Example 1 is saying calculate. So this is the question. Calculate the number. So they want you to calculate the number. So calculate the number of moles of carbon dioxide. Of what? Of carbon dioxide. So of carbon dioxide molecules. Let me use a different marker. Carbon dioxide molecules. So carbon dioxide molecules that are present in 240 cubed centimeters, or so I will just say at what? At, so let me do this, at RTP, at RTP. So if you look at this question, they are telling you number of moles. You just see volume. Just know that the formula you are going to use is number of moles is equal to volume over molar volume. Where is the molar volume coming from? From this that is written RTP. So what I'm going to do is that number of moles is equal to what is the volume? The volume that is given in this case, This, have you seen, this is the one that is given. So this is what? This is 240. So I'm going to say 240 like that, cubed centimeters. So even the molar volume, I'm going to use the one that is in centimeters, which is RTP. It is what? 24,000. So 24,000 cubed centimeters. If I divide here, the answer that I'm going to get will be 0.01. Since then I'm calculating number of moles, so I just say 0.01 moles of what? Of carbon dioxide. So I've answered the question. This is the answer, just like this, no panic. So this is how you are supposed to answer questions in an exam. These are ways that you need to take note of. So even as you get to answer questions in an exam, you just need to understand questions critically. The same way you say, okay, volume, the formula I'm supposed to use, is that formula under volume? So this is how we get to answer questions like this, and this is how you just have to answer them. Let us look at question 2. So let me say this is a question 2. I will say this is a question 2. How then can we go about this particular question? The question is saying, what is the volume? So what is the volume? So what is the volume of, so what is the volume of the following? What is the volume of the following gases? Following what? Following gases. What is the volume of the following gases at STP? So you are given such a question. The first one, A, that is given, they're telling us 2.8 times 10 to the power 3 moles of nitrogen, like this. So how can you find the volume there? I've already told you that volume is equal to what? So for us to answer this question, I'm just going to say volume is equal to number of moles times molar volume. This is the formula. So where I'm going to say number of moles, it is this one. No need of panicking. 2.8 times 10 to the power 3 multiplied by molar volume, RTP. So at RTP, the standard one that you are supposed to use, that is 24. So I'll say 24 cubed dense meters. So if you multiply this, the question is saying standard temperature and pressure. So standard, so meaning the volume here is 22.4 dense meters cubed, like this. Where I'm going to say, what is the answer if I multiply here? The answer that I'm going to get here, what is the answer? So you get your calculator, multiply, confirm with me. I'm getting 0.0627. Then I just say dense meter, cubed dense meters. So this is my answer. I'm done with that. This is what I'm supposed to do. So even yourself, this is how you are supposed to be answering questions. Have you seen? I'm not even panicking because I know these things and I've applied them. We've been doing these things and you are getting used to this, so you should not even be afraid of any question. We move now to B. Let's say you are told to say you want to calculate. So you want to calculate the volume when you are given now the grams, 3.2 grams of oxygen. So you know that the formula that you are supposed to use should be volume is equal to number of moles times molar volume. Where you don't have the number of moles, but you are given this, you are able to calculate number of moles. Using that formula, number of moles is equal to mass. What is the mass? 3.2 over, what is the molar volume? Molar volume of oxygen. So molar mass, I mean. This is mass over molar mass. Number of moles is equal to mass over molar mass. So here we are saying molar mass. Molar mass of oxygen. So since there is a 2 here, you know that mass number is 16. 16 times 2, you get a 32. where you are going to get number of moles is equal to what? When you divide there, you are going to get 0.1 moles of what? Of oxygen. So of oxygen, so this is the one you are going to put here, 0.1 times molar volume is given RTP, so standard temperature and pressure, which is just 22.4 cubed dense meters. So just like this. So you multiply, when you multiply, what answer you get in there? So when you multiply, what is the answer? The answer that you are going to get is 2.24. Kindly confirm with me. 2.24 cubed dense meters. So cubed what? Dense meters. Of what? Of oxygen gas. So this is the answer. Just like this. The same way I've answered this one. This is how you are supposed to answer. No panic. You are supposed to be answering these things without any form of panic. So let's make sure that we are able to move together. Let's make sure that we are able to excel in these things together. So this is where we are going to end from. Let me give you an exercise. I see how you are going to answer that one. So I give you an exercise. I see how you are going to come up with the answer. Just some simple questions, just 2 questions. I see how you are going to answer them. So let's see how we are going to answer these questions.